Okay, so I'm going to continue from where I stopped the other time. We're still designing our vending machine. So we've been able to get to Q3, and we're fine on Q3. Like I told you, a way of knowing if you've done a good job on a state is to make sure that you have an output of all the alphabets going out from that state. So if you look at Q2 here, I have 1 going out, I have 2 going out, I have 5 going out of the state. Then that means that the state is safe, no matter what. Now, hackers or any security breach cannot attack my system at that state. Same thing with Q5. I have 1 going out, I have 2 going out, I have 5 going out of state. So we're at Q4 now. Don't forget, state Q4 is a state where we have 4 naira already. Either by 2 from Q0 to Q2 and 2 again from Q2 to Q4, or 1 1 1 1 from Q0, Q1, Q2, Q3 up to down to Q4. Or again, look at this: Q0 1, Q1 2, and Q3 1. That's still 4. Anywhere you put it, we're still on 4 naira and at this point of Q4. So at point Q4, where I have 1 going out to 5. What if someone then decides to put decides to put 2 naira at this point Q4? That'll be 4 plus 2, that'll be 6. So obviously we're still going to go to our final state, although that's 6 naira, but the person gets to get the orange but loses 1 naira. Yes, loses 1 naira. So what if the person again puts in 5 naira from this stage of Q4 where we have already have 4 naira? It's a possibility. In system design, you don't leave anything to chance that it's going to happen. You think about all possible situations and scenarios. So for me again, we can still do from Q4 to Q5 and put it as 5 naira. Now, if we do that, obviously that's 9 naira. The person still get the orange but loses 4 naira because, as we've been told, our machine does not give change. So now, at this point, we are through with our system design. We are through. Whatever it is, you then make cut from Q4. Actually, at QF, some of my students will tell me, okay, at QF, what happens? Whatever it is you want to happen happens. Maybe after the transaction, you may want to make it go back to Q0. Some people say they will loop it over as QF. Either way, but that doesn't matter. At this point, you've got into QF and you've got in orange. Now, let's test this machine and let's see what happens. Let's test it out. So to test this machine, we come to test over here. So yes, tests. No, we come to input. So there are various ways you can test out this machine. So let me use step by state. So let me see let's not think of various scenarios various combinations that will give us 5 naira. We can have 1 2 2. Would this work? 1 2 2. Let's try it out. So at this point we have 1 2 2. This is what we want to test from step 0 from state 0. 1 2 2. So if you click on step, you go to Q1. If you keep on step again, it goes to Q3. You click on step again, you go to, it's green. That means that our machine accepts this string 1 2 2. Let's reset it. We're supposed to close that and test it again. Input again. Let's see another one. Let's try fast run. Let's do which combination again can we try that will give us 5 naira? 2 1 2. Yes. Let's see if we've been able to implement that 2 1 2. Let's click OK. Now, fast run shows this: accepting configuration found. So from here we have from Q0 2 takes us to Q2, 1 takes us to Q3, then 2 again takes us to KF. So assembly state, assembly combination found. That means that 212 is accepted on our machine. Let's try. Okay, we're supposed to test before. We've tested with 2. Let's see which other one we can. We don't need multiple run. That's it. You want to run. So if you want to have, you have two things you want to run. But let's see. So let's try 2 2. No, we've done 2 2 1. Let's do 1 1 1 1. So let's see the results. So does it accept that? Inputs, results. Oh, okay. I think let's try 1 1 1. Okay, that's 1 1 1 1 1. That's 4. Okay, good. Let's see it like that way. Let's try 2 2 2. Let's try that too. So let's say run inputs. Now you can see the one that was accepted, the one that was rejected was rejected. So you can also use this to run your test to see which accepts and which rejects, of course. So we've tested with now obviously this is 4 naira. 4 naira didn't get to the final state, that's why this was rejected on the machine. 222 will be accepted, but of course you know what that means. That's 6 naira. Our machine gives out the orange at 5 naira, but will not give you a 1 naira change. So that is a good design that we've done. You can test it out and test other inputs that you may want to test out. But don't forget, we are not through with this. We've already been able to design our machine effectively, and it's a good machine. All possible states have been taken care of. You can design it again, like I said, try multiple inputs, try other ones. There is no combination of 1, 2, or 5 that our machine will not accept. So back to the question. So let's just finish up the question now. Design it. We're going to do a good design. Test your design with 4 sample strings. We've been able to do. Obtain formal description of the machine. Now, formal description of the machine, like I said earlier on, we must go through the 5 tuples. Now, okay, this was one I designed some time back, but it's about the same with what I just designed now. So now for the 5 tuples of the machine, the first thing is, okay, this is the testing I was trying to do on my own. So we've done it on JFlap, so we don't need to go over this again. This is just for you to show in an exam. This is how you're supposed to, or formally, an exam, if you're doing it for someone, this is how you're supposed to present your results. Now, you want to test 5. What this means is that you want to test 5. If 5 is absent of the machine, so at Q0, you put in 5. You go to state Q5 is accepted. You want to test 1, 1, 1, 1, 1. So at Q0, you put in 1, takes you to Q1. At Q1, you put down 1, takes you to Q2. At Q2, you put down 1, takes you to Q3. At Q3, you put down 1, takes you to Q4. At Q4, you put down 1, takes you to Q5. It's accepted. So same thing with 2, 2, 1. Same thing with 1, 5. So in an exam, this is how you're supposed to answer the question. That's why this was put there for you. But for this class, for the assignments you're going to send to me, please do it on JFlap. Please do it on JFlap and screenshot your results to me. That's what I would expect for the assignments. Now, back to the last question. Obtain the formal description of the machine. So obtain the formal description of the machine. You're first supposed to look for all the states. We have states Q0 to go to the Q0, Q1, Q2, Q3, Q4, and for this particular one I did, I had Q5. But for what we did now, we had QF. So it's best to just put it as QF. So I've changed it to QF for consistency. So our sigma is 1 naira, 2 naira, and 5 naira. Then Q0 goes to Q naught. Q naught, which is in initial state, is just to say that our initial state is Q naught. Of course, we don't have to use Q. We can use ABC. We can use 1, 2, 3, whichever one we use. Just to say that if it is 1, 2, 3 used, you can say Q naught equals to 1 or Q naught equals to A, or whichever one you want. Our F, which is the final state, can be more than 1, but for this particular situation is 1. So it's QF that we are using here. So that's why we have QF over there. Then the transition function can be done using a transition table, whereby we have Q1 again. I need to change this to QF since we're using F in this particular example. So now we have Q0 to QF, all the states. Then we have the inputs, which is 1 naira, 2 naira, and 5 naira. So then we from the table, from the design. So if you ask Q0, if you see a 1, where should you go to? If you see a 2, where should you go to? If you see a 5, where should you go to? Again, I'm supposed to change this to F, and F. So please, like that. So you can go through the design, go through the table. Now, this is the formal description of the machine. So we've been able to design this machine. So we'll continue in the next video. Thank you.